All right. Let's look at example 13. You want to find the values where f of x has a horizontal tangent line. Does anyone have any thoughts on how we can approach this problem? What do I need to do? Can you outline the strategy for me? Feel free to unmute yourself if you have a good strategy. I mean, I could just tell you, but it's better if you tell me. How do you figure out where the tangent line is horizontal? What's the very first thing I should do? Not sure.
You find the slope.
What do you mean by the slope? How do I find the slope?
You integral it.
Did you say integral?
I mean, you make this thing become 2x squared minus 14x plus a, and then you gotta find the y and x point, and then from there you can know the line, how's the shape of the line.
Okay. I like a good deal of what you had just said there, for sure, Reagan. The first thing is, anytime we're talking about slopes of tangent lines, or let's unpack it further. When I see this phrase, horizontal tangent line, maybe not yellow, let's do it in green. When I see this phrase, horizontal tangent line, to me, that means the slope of the tangent line is 0. Horizontal looks like this. And this is slope 0. That's slope 0 because it doesn't matter what your run is, your rise is 0. So 0 over whatever the run is 0. The second thing I would say is that once I realize I'm looking for the slope of the tangent line, we're really trying to say, oh, this means find the points where f prime of x is equal to 0. So when Reagan gave his explanation, he was basically saying, take the derivative. And that's what I'm trying to say in red over here. We got to take the derivative and we got to set it equal to 0. Okay. So let's do that. We take the derivative, you get f prime of x. Take the derivative of this first term. That's going to give you a 3x squared. Take the derivative of the second term. That's going to give you negative 14x. Take the derivative of this third term. That's going to give you plus 8. The derivative of the last term is plus 0. I'm not going to write that. Oh, if I just looked up, Aram typed the answer in the chat box for me. Reagan read it off originally. I take the time to explain it just because a lot of our classmates have not had calculus ever. And I don't want them to feel like, oh my God, this is going so fast, I cannot keep up. Try to hit some sort of middle ground here. Now I got to set this equal to 0. And we want to be able to factor this. So we know that when I multiply the first two terms together, I should get a 3x squared. So one of them should be 3x and the other one should be x. I know that when I multiply the last two guys together, I should get a positive number. But when I add the middle, the outside and the inside together, I get a negative number. So that means that this should be a negative and that should be a negative. And then I just got to find the right combination of numbers that multiply together to give me 8. So that when I FOIL, I'm going to get a negative 14 in the middle. So what could work here? Maybe I have a 2 and a 4. So if I put a 2 here and I put a 4 here, maybe this works. Let's just check. The first is 3x squared. The last is positive 8. So those parts work. The outside is negative 12x, and the inside is negative 2x. Negative 12x plus negative 2x is negative 14x. Once you look at those, you got those two zero factors, that tells you that 3x minus 8 is equal to 0, and x minus 4 is equal to 0. So these guys give me 3x is equal to 8, or x is equal to 8/3. And this one gives me x is equal to 4.
Wait, isn't it 3x minus 2 instead of 8?
Thank you. For sure. You guys need to keep an eye on me always, because I do that stuff all the time somehow. Does that make sense to you guys? If you want to avoid factoring, you could always just use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that's for polynomials that look like this. 0 equal to ax squared plus bx plus c. So that works as well.